addition of all forces on the desired axis. So I know that is along X, I just look at what is going on along X. And the only force that I see along X, in this particular case, is Fx. So Fx is the only force, the component of the force along X equal ma. If I am calculating for A, will be just the force cosine theta, which is the X component, divided by the mass. This will be how to find the acceleration. Of course, I can change the problem. In the study guide, I gave 2 forces instead of 1. Instead of pulling, I can push the object. So those are differences that you can know. All right. After that, you just substitute and calculate. This is the algorithm you will follow for all complex Newton laws. I mean, where you apply Newton laws problem. Newton laws law. Newton law. Okay. Then I ask for the normal force. Is the normal force along X or along Y? It's along Y. What will be the algebraical addition of all forces along Y? Fn minus Fg plus the Y component here. And from there you find the normal force. That's it. This was the problem, the last problem. Okay. So another problem, applying the Newton laws, is when I can ask for example, in an elevator, there is an object, I mean, there is a person, and there is a scale. This is the scale in the elevator. And there is a person. So I can ask what is the apparent weight. Apparent weight is the same than the net normal force, the magnitude of the net normal force exerted by the supporting surfaces. Can be 1 or can be 2. In this case, it's only 1 supporting surface, which in this case, on the person, is just the elevator. So the elevator, I mean the scale. The scale is acting here, not the elevator. Only the scale is acting on the person. So if I ask, if I give the mass of the object, for instance, let's say it's 60 kilograms, I can ask, find what will be the apparent weight on the person. Apparent weight is the magnitude of the net normal force or net force exerted by the supporting surface. This is the definition of apparent weight. Or what is the reading on the scale will be the same. Find the normal force. So find the reading on the scale, or find the net force exerted by the supporting surface, or find the apparent weight. So when you enter to an elevator and you go up and the elevator is fast, accelerate, fast, how do you feel? Heavier or lighter? Heavier. So your apparent weight is greater than your actual weight. When you are going down and the elevator is accelerating downward, how do you feel? Lighter. So your apparent weight is not your true weight. It's how do you feel. When you are in a roller coaster and you are on the top of the loop, how do you feel? Heavier or lighter? Lighter. So your apparent weight is almost 0. And it's what we call the zero gravity, or the state of weightlessness. The same thing, apparent weight. Why? Because the seat belt, or the seat in that case, is not touching much your body. Since it's not touching much your body, the normal force is almost 0. And that's the reason that you feel weightlessness. So you feel like you doesn't have any weight. So because the normal force is what is telling you how heavier or how heavy are you in those situations. The same will be here. So when you push the scale downward, the scale has a bar or something like that attached to the needle. And the needle is the one that marks. But what is measuring is the normal force. It's not your weight. The problem is that when you enter to the scale, you let the scale to be in equilibrium, right? When reach equilibrium, then you measure your scale. You never measure when it's unstable. So you want to see why, because what is measuring is the normal force of minus mg equal to 0. And what you read, or the reading in the scale is the normal force. But your normal force will be equal to mg because it's in equilibrium according to the Newton's first law. So what actually measured is the normal force, but it's calibrated. Otherwise, if you enter to Publix, 800 Newton in the scale, you will go out. You won't buy it. So Fn minus Fg equal to 0, but they calibrate. They divide by 10 or 9.8, and that's what you see. All right. This is what we call the apparent weight. Now, sometimes the scale is not in equilibrium, like in this elevator. The scale is not in equilibrium, not necessarily will be the same weight. Will be the same weight if this is at rest. If the elevator is at rest, what will be your normal force? In this case, will be according to the Newton's first law, because it's at rest, Fn minus Fg equals 0, Fn equals mg, which will be 60 times 10, approximately 600 Newton. That will be your normal force, and that will be your weight, right? Let's say that the elevator is moving at constant velocity. Which Newton law we applied in order to find the normal force for apparent weight? The first law. Because it's moving at constant velocity, it will be the same situation as it was at rest. Fn minus mg equals 0, and Fn will be mg. But there will be situations when the elevator is accelerating. So if the elevator is accelerating upward, so find what will be the reading on the scale, the normal force. In that case, it's the only force, normal, because that's the only one, that will be the apparent weight, the reading on the scale. So, we draw the row diagram, like in every situation. This is finding a particular force, and we use this algorithm whenever we are looking for a particular force. And Fn is a particular force. So Fn, we draw now on the scale what are the forces, not on the scale, on the person, and Fg. This is my row diagram. Because it's very simple, I mean, I can draw the free body diagram, but when you get expertise, you don't have to be so specific. You can immediately recognize that this is Fn minus Fg. Fn and Fg, this is my free body diagram, where the arrow means positive direction. Okay, we finished with this step. We go to this one, which Newton law and along which axis, because the elevator is accelerating, sigma f along y equal to what? Ma. Now, what will be the algebraical addition of all forces along y? You look at the free body diagram, and we recognize that the Fn is upward and Fg is downward. So the summation of all forces along y will be Fn minus mg, which is Fg, equal to ma. Fn is equal to ma, or mg, plus ma. So, to your weight, you are adding another element. For this reason, you feel heavier. So if you have 60 kilograms, 60 kilograms times 10 is 600, plus 60, whatever is the acceleration. Let's say that the acceleration is 0.2. 0.2 meters per second square. So, or let's say 2 meters per second square. How much will be your apparent weight? Will be 600 Newton plus the 60 times 2, 120. You will feel like your weight is 600 plus 120, 720, which is approximately 72 kilograms. So this is what you feel. Instead of feeling that you have a weight of 600 Newton, what you feel in that situation is that your weight increased by 12 Newton. Any question? Going down.